The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Depending on where you're logging in from today, one of those will sound just about right. Welcome back to another great episode of our Best Practices webinar series with 7Signal. I see a decent amount of you have logged in early today. Thanks for doing that. If you'd like to, let us know where you're tuning in from. If you're working from home, if you are working in the office today, I myself am switching things up this week. I am back in my apartment in downtown Cleveland working from home today, and I am joined by our special guest, Chris Minton, who is joining us from Texas. Is that correct, Chris?
That's correct.
How are you doing today?
I am right as rain. Thank you, Kelsey.
Awesome. Well, glad to have you here, and I see a lot of you dropping in here. We have Jeff joining us from sunny Galion, Ohio. Thank you, Jeff. We have Karsten joining us from Germany in the office today. Thank you, Karsten. We have Jan joining us from Italy, working from home. Thank you so much for tuning in. And I see a couple more of you dropping in. Please continue to do so, and we'll circle back with you later as we get started here. So we are 7Signal, the leader in wireless experience monitoring, and we'll go a little bit more into depth before we begin as to what our mission is as 7Signal and what that means. So we have a great topic here today. We have understanding the common problems related to high user densities and outlining effective strategies to prevent those problems. And as I mentioned, we have with us today Chris Minton, our solutions engineer at 7Signal, and I myself, of course, am Kelsey Rizzuto, the marketing specialist here. Really excited to dive into this and to hear from all of you. So as we go through the presentation today and Chris is moving along, if you have any questions, feel free to drop that in the questions panel, and we'll cover that at the end of today's broadcast. A couple of announcements before we begin. Some of you who have recently joined us, these will all sound familiar, so just bear with me here. We do partner with CWNP for every single one of our webinars, so if you're pursuing a certification, you are eligible for CE credits by attending today. So if you would like that, we can easily send over a PDF certificate from today's webinar via email. We also host a product tour every single Friday at 12 noon Eastern. At that registration link there, go.7signal.com/tour. And I'll go ahead and drop that in the chat here as well if you'd like to join us this week and learn more about all of the exciting updates with Mobileye and SapphireEye. We also send out a newsletter, the Troubleshooter newsletter from 7Signal, every other Wednesday. So if you aren't currently receiving that and would like to, I'll go ahead and drop a link here in the chat in addition to the product tour link, so you can go ahead and sign up for our distribution list. We also post all of our slides from each presentation to our Twitter account. So go ahead and give us a follow at 7Signal, and those will be up there later this afternoon. But if you aren't on Twitter, no problem at all. You all will receive the presentation slides and today's recording in a follow-up email for registering and attending. We also post all of our archived webinars to our YouTube channel, so go ahead and give us a follow there as well. Look us up at 7Signal. You can go ahead and rewatch all of the past topics that we've covered, and of course today's presentation will also be up there later this afternoon. Another exciting announcement here, we have a very exclusive webinar next week that we're excited about, how the post-pandemic era will change remote working, with special guest Jeremy White, executive editor at Wired. And we'll go ahead and send out the registration link in here as well, so you can join us next Wednesday at this time, 11 to 11:45 a.m. Eastern, and register early. And we're looking forward to all of you joining us. Okay, a little background on 7Signal before we dive into the presentation. We were established in 2007 in Helsinki, Finland, and we're now located in lovely Cleveland, Ohio. We've hit a lot of major milestones along the way that we're proud of, such as the 1 billion data points that we're analyzing daily, in addition to the 5 million devices that we're monitoring daily as well. We have over 200 customers, 15 patents, which goes to show that the technology that you see from 7Signal, you're only going to see from 7Signal. So to give you a background as to what makes us so different at 7Signal, if you look at your typical enterprise LAN infrastructure here on the right, you've got great tools, great technologies installed on the network, giving you really useful feedback, useful data, such as your Cisco, Aruba, Riverbed, AppNeta, and more. But we pick up where they leave off, moving into a different space. And we'll start here with Mobileye. Mobileye gives you full visibility into the user experience and can be installed on the individual devices themselves, monitoring the experience from the end user perspective, ultimately monitoring from the edge of the network. Mobileye can be installed on any Mac OS, Linux, Android, or Windows device. And as you can see here, ultimately any mobile device, such as your mobile phones, your laptops, your Zebra scanners, workstation on wheels, and more, giving you that full perspective into those external networks. And we're here because the digital experience matters, and it matters no matter where you're logging in from for the day, and we understand that your work is still mission critical working from home. So Mobileye can give you that full visibility into your external home networks as well, with a lot of us working remotely today. Additionally, we have Sapphire Eye, which are the sensors for service level quality and RF visibility. And through this combination, you're really gaining a full holistic perspective as to what is occurring in your network that you just can't find anywhere else. All right, thank you for that. We're going to go ahead and kick off today's trivia question here that Chris graciously provided us. So let's see how you all do here. All right, Chris, can you see this question?
I can.
Perfect. Voice applications need what percentage of available airtime utilization for maximum performance? I see a lot of you dropping your answers in here. We have some mixed results. Okay, give you a couple more seconds, and I'm going to go ahead and close this. All right, Chris, how did we do?
Yeah, this is a little of an interesting one. So the answer is 50%. If you have issues with that, it's straight from the CWDP 303 best practices guide. So you know where to go, but they recommend 50%. Mm-hmm.
Awesome. All right. Well, thank you, Chris, and thanks to everyone for dropping those answers in here. Mm-hmm. And with that, I'm going to go ahead and pass our controls over to Chris here so he can dive into today's presentation.
Great. Thank you, Kelsey. Can you let me know when you can see my screen?
I can see your desktop, but yes, I can see your screen.
And then...
Perfect.
Okay. And is my voice coming across clearly?
Yes.
Perfect. Thank you, Kelsey. So thank you, everyone, for joining today. The topic of discussion is understanding the common problems related to high user density environments and outlining effective strategies to prevent the problems. My name is Chris Minton. I am a sales engineer with 7Signal. My CWNA number is 974-472. Let's talk about the agenda. So we are going to talk about with high user density environments, how do they present problems to the end user and to the Wi-Fi administrator? We're going to talk about what type of problems can arrive because of high user density environments. And most importantly, what are some effective strategies to prevent problems in high user Wi-Fi density environments? And if we have time, we'll do Q&A. If you've got a question that Google can't answer, feel free to throw it to here. I will try to answer it. And if I can't, I will Google it and maybe reply, maybe not. We'll see. Yeah, of course, I'll find you guys afterwards and find the response so I can. So let's get started. So topic of discussion today is high user Wi-Fi environments, right? How do they present problems to the end user and the Wi-Fi administrator? I want to level set real quickly about what we're talking about. We're not talking about the easy here where you have just been awarded the contract to do the Wi-Fi refresh for the Dallas Cowboys Stadium, right? That is obviously going to be a high dense environment. We're not talking about stadiums. We're not talking about gyms. We're not talking about churches and synagogues, basketball stadiums, auditoriums, conference centers. So those are all pretty much understood that they're going to be high density environments. And what I mean by high density is a lot of access points and a lot of wireless clients. what I want to talk about and frame this best practices guide in this conversation is to the areas where you might not know or realize that area, and again, area, physical space, is actually a high dense environment. There is no flashing light that says, hey, there's too many Wi-Fi clients on this environment. There's nothing really that says that this is a high dense environment. Now, you can go with the original of saying, well, if you have a stadium, how many people, how many devices, and you can do the math and get a good idea. But this conversation is where I'm seeing a lot of other conversations with customers is, my goodness, my environment has become pretty high dense. And again, because of COVID and working from home, this has been a little bit on the back burner. But as things are hopefully thawing out and people are coming together with Wi-Fi clients and coming to the area, this is something that we want to focus on. So keep that in mind when we're talking about these conversations. So the first people to always find issues right off the bat is not your network monitoring tools. It's going to be your end users, and especially in Wi-Fi. Every single time, your Wi-Fi customers, your endpoints, your clients, if there's something happening, they're usually one of the first ones to see it, right? And it usually presents itself in four problems, or four areas. In application timeouts, the download that they have, the speeds are slow. VoIP drops, which we'll talk about here in a little bit, and the upload is slow. Now, we're looking at not just a Wi-Fi problem, but is this a Wi-Fi problem because there's too many wireless clients? So these are the main four that will pop up. There are others, but let's talk about what a Wi-Fi environment should actually look like in best practices. So on the next slide, and you'll see the asterisk appear with application timeouts. This is the 7 Signals Best Practices Guide. You'll see a double asterisk, which is CWDP 303 Best Practices Guide. So if you have your Wi-Fi network to fit all of these percentages, your Wi-Fi network is Mary Poppins. You're perfect in every way, right? And this isn't just like it hits this every once in a while. This is 6 nines. If your Wi-Fi network runs at these benchmarks, you're in a good shape. Application benchmarking and application testing is not in scope for this presentation or possibly even in this topic, right? But if you're just responsible for the Wi-Fi, or you're just focused on just the Wi-Fi and responsible for everything else up the stack, 7 signal, if you've got these, you're good. If you've got a signal strength of greater than 65 dB, CWDP 303 exam says 67. Again, that's related around to voice, and we'll talk about that. If you've got SNR ratio, if you got that delta of 25 dB, you're good shape. Client count per AP, not per channel, less than 30. Channel utilization, I want to really look at this and make this a topic here, because you're going to see a reoccurring thing pop up with high density environments, under 40% utilization. And your data rate, higher than 12 megs per second. We'll talk about that. And then another one that I really want you guys to focus in on is retry rates. If you've got retry rate over 40%, we've got some issues, and those issues might likely be because of other Wi-Fi. As our VP of Customer Support and Enablement likes to say in his presentations, that the biggest interference in Wi-Fi is other Wi-Fi, right? And you're going to see that hands down with retry rates. So let's talk about the benchmarks and the KPIs that we'd expect for your up the stack, right, for web page download. So we're talking about 5,000 milliseconds or 5 seconds. Go to the internet box, type in Google, hit enter. You should have the page load up within 5 seconds, right? That's what your end users are looking at. When we move into voice, we have a packet loss less than 1% is acceptable. Anything over, not good. I want to draw your attention to the possible reason, most often due to interference or low signal level. Result is a network retry. Only in Wi-Fi can a ping be lost and the networking and up the stack is still up and running, right? Wi-Fi, when you lose pings, that's an indicator. When you have a packet loss of more than 1% packet loss, there is something going on. What is going on? More than likely, it's interference, low signal level. Same thing with latency, 150 milliseconds. That's some magic number with latency. We'll talk about that here. We're referring to voice. But notice this, typically points to network congestion. Now, when I say network congestion or network reach hour, we're not talking up the stack. We're talking from the client to the AP. We're not talking to the default gateway usually, right? This is pure Wi-Fi. And then again, jitter, again, less than 10 milliseconds, you're good. If you've got jitter, the audio obviously starts to be choppy, but look, again, this recurring theme, what's a possible cause of jitter in a Wi-Fi environment? Interference, network congestion, right? That leads to low MOS scores. MOS, if you have the ability to measure with it, 3.6 is what you're looking for. And you'll see this magic number, interference and congestion, right? Those are the main reasons for things to drop. Your end user, this is a pretty high benchmark, I think, especially for TCP, UDP, layer 5, excuse me, layer 4, layer 5 level upload. 5 meg is pretty decent upload, but rule of thumb for business critical, 5 meg is per client is a steady rate for throughput. Anything less than your users will possibly notice. So let's talk about the problems that can arrive because of high user environments. So we've talked about how they present themselves to the end user. So I picked 4, right? So here are the 4 problems. There are others, and 2 of them we've already talked about, but 2 of them are new. We've got limited available airtime. We've got congestion, our friends packet loss and latency, and then limited throughput. So by 7 Signals definition, if you're curious about available airtime, our definition is the total airtime percentage on the same channel as the access point. And then our Sapphire eyes, which are our high performance sensors, that's the actual equation that they use to sparse out the service level for airtime. And then congestion, simple definition for congestion, the Wi-Fi network is that it'll utilize. So congestion can be caused by one or all of these issues. Channel utilization, if it's over 40%, client count per AP, if you've got more than 30, I have seen congestion with as little as 4 people on the same AP, and the retry rate is if it's greater than 40%. If you have a retry rate that's higher than 40%, there's an issue. There's congestion. And there is possibly congestions by interference, right? And there's going to be this recurring theme about high dense environments, high users, right? Packet loss, you'll notice the double asterisk up there in the top. This is CWDP 303 best practices. So this is, again, you'll notice that due to interference or low signal level. Agreement, again, less than 1%. For Wi-Fi, latency, again, 303 best practices guide. This is the CWP 303 design professional. High latency points to network congestion. Latency service level agreement is 150 milliseconds. There's that magic number for latency. Because what are we designing our Wi-Fi networks for? It's voice, right? That's the target we want to hit. So again, 303 best practices, 150 milliseconds or better is the latency that you're looking for in the environment. And this is not just once in a while, this is 6 nines, right? So limited throughput, we've touched on. This is where people will start to see sluggish performance. Again, 5 meg is usually the rule of thumb. This is 7 Signal best practices. And so we've just mentioned, just real quickly, the 4 problems, the 4 causes, right, of these of high environments. So just like if you watch YouTube and you watch spoilers, and they have this point where they say, if you haven't seen the movie, pause here, spoilers ahead. This is my spoiler moment to you. If you have not identified your environment as being a high dense environment and is having issues, do not do these recommendations that we're about to talk about. Full disclosure, full stop. This is something that should be done if it has been identified that you have a high dense environment that is causing issues and you're looking at things to resolve that. Just like the CWNA with the troubleshooting track that they refer to, there are very specific processes that you want to do and measure and time to improve your Wi-Fi network. So again, full disclosure, spoiler right here, don't just hop on the network after this call and start making some changes. Wi-Fi is something that you need to look at over time. And when I say time, not just 5 or 10 minutes, I'm talking months, especially if you have an environment. The Wi-Fi's medium is air. Air is always changing. There's always things being added and subtracted. You need to get a nice base rate of what's happening in that environment before moving on. Okay, so spoilers ahead. So I've listed several, and I can already tell my time's going a little high. So I'm just gonna mention the others. If you guys have some other ideas, feel free to throw them into the chat window on if you've seen some experience and what you guys have done. But the first one to how to fix this is to use only 20 megahertz wide channel widths. Right? Number two, this is always one of consternation. I can see the topics already popping up. Lowering AP power. And we'll talk about that. Something we haven't really addressed right now is probe and beacon modification, which is really interesting and is really going to be solving the problem that is the problem. And then moving to a 5 gig only design, 5 gig band. So I've been doing Wi-Fi for a long time now, and in the last couple of years, I'm seeing more and more 5 gig only customers, which is fantastic. So some of you guys are saying, yeah, that's a no-brainer. We've been doing 5 gig only for years. Other of you guys are like, man, there's no way I can get off 2.4. I get it, right? There's other options you can do besides just to turn off 2.4. But it is becoming a little bit more prevalent, but that doesn't fix everything. Just turning to 5 gig on gigahertz radio into the band does not just automatically fix this. There's some stuff in that, and I'd like to show it to you guys as well. So what will moving all of your channel plans to 20 megahertz wide, like what will that do? How will that fix a high user Wi-Fi environment, right? So the base of it is, again, 47 signal, right? 20 megahertz wide channels, you've got smaller contention domains. You guys remember the definition of contention? It's just time, to communicate time on the network. Basically, if everything works right, you give the client more opportunity to transmit. Now, I mentioned up here in the middle where to do it and what to do. So everybody's network on your controller base, if you've got on-prem, if you've got cloud, if you've got autonomous, if you've got split MAC, it's all a little bit different on where you can do this. So just kind of think about this in your environment. But what you do is you just set the channels to 20 megahertz, right? That's as wide as they go. What you want to do is also, you want to remove all bonded channels, right? So double asterisk, this is 303 best practices for the design professional, right? There's no need to have 40, 60, 80, 160 bonded channels when you've got a high client, high density environment. You don't need to. You go ahead and just throw it down all to 20, right? Now, once you've done that, what are things to watch for, right? Keep an eye on the airtime utilization on the channels. Keep an eye on the retry rates. Does anybody remember what our SLA for retry rates are, right? It needs to be less than 40%. Client counts per AP, again, best practice is 30. That's quite a bit. And then also something that was really interesting with the 303 best practices guide was that if you're doing dynamic channel assignment instead of a static plan or auto, if you need to change channels, man, schedule it to do it off hours, right? We'll talk about that here in a second. That's related to some other things, but I wanted to throw it there in the channel list as well. And then let's validate this, right? This is CWNA, best practices again. Let's validate this. You need to have spectrum analysis running. It needs to be there. It needs to be stationary. It needs to be running for a long time, not just 5 or 10 minutes. You need to get good data, a good sample. And then also use your controller reporting information that you have. You can do a lot of, doesn't matter the vendor, everybody all has reports on how the channel widths are behaving. So let's move on to number 2, the most, let's say the most contentious topic of these is lowering the AP power, right? So you've got a high environment, you've got a high density user environment, you've made the decision that that's what it is, and you're thinking about lowering the power on these APs. So what does that do? Well, lowering the power lowers the coverage cells. The idea is that clients that are closer to that AP are going to stay to that IP and they'll connect to that best IP. again, this will have a ripple effect into the area, and this will say, more APs, less clients per AP, and then the clients then will have, higher data rates, right? Because there's fewer connections, client connections, and a few other things, right? Again, 303 best practices. Where to make this change, where to do this, depending on your architecture, controller per AP, and then how to do this. So you're basically creating less co-channel interference, also known as co-channel contention, a 303 topic too. And I really like changing CCI to CCC instead of having CCI and adjacent co-channel interference. I really like the naming of CCI to co-channel contention. I think that resonates a little bit more for me in my limited understanding of Wi-Fi. I think that's a great terminology for it. But again, it's the same, really basically the same thing. And what we're doing is we're forcing higher data rates for clients, right? We'll talk about this here in a second with the probes, and we're creating a smaller cell size. So what to watch for after this is done, or when you're looking for, is, look at the percent of management frames airtime utilization. The thing that's causing the problem is the thing we're trying to fix, right? The net of all of this conversation for this type of environment is that usually what is causing the issue is too much management overhead traffic in the environment. How to fix that is to throttle that down, to let your client Wi-Fi devices have as enough and more and contention to be able to communicate and move on, right? That's the goal here when we have a ton of APs and a ton of clients in a very small place, roaming or not, and we'll talk about some roaming as well. One thing to watch for is cell gaps. Now, this is again, straight from 303 best practices. This is the CWDP design professional track. Cell gaps. If you move your channel plans and make it smaller, then all of a sudden find a gap somewhere, it is not recommended just to go triangulate the 3 closest APs and then turn those power, crank those things up to 11. You don't want to do that. Best practices is throw another AP right there and keep the power low, right? So you see a cell gap, keep an eye on it. Again, 303 best practices. Don't crank up to the neighbors. Go address it with an AP with the same similar power plan, because we'll talk about that with probes and beacons here, right? You'll also notice that when you do drop these environments down to lower power, and I've seen this too, is that roaming issues become very prevalent. And so that's an eye on it, that maybe something is a little too fine-tuned, a little too low power. Just keep an eye on if the roaming issues have started up, more so than before, right? Again, how to validate over time, and use that spectrum analysis and use your control reporting, right? You definitely want to have that information. So here's the great topic here: probe and beacon modification. So how does modifying these guys, how does this help, if you've got a high user Wi-Fi dense environment? So I just want to throw a little bit of background for those that know and those that don't, is that, think about your environment that you're managing right now, or you're building or responsible for, and think about all the SSIDs in that space. So every AP sends a separate beacon for each SSID it carries 10 times per second. And that's quite a bit. And here's the catch though: beacons are sent at the lowest basic rate, right? To ensure that every possible client in that range of the AP can hear them during a passive scan, right? So think about every AP in that distance. Think of the size of the beacons and think about the client that when it does an active probe, it's probing a channel every 10 milliseconds, right? Even the client, most time when they do an active probe, they'll probe a channel, 10 milliseconds, they'll move channel, they'll go to another channel, go to another channel, right? Sometimes the APs, again, if we've got a low data rate and you can hear it, some of those APs way across, physically away, they're going to respond back to that. Well, what happens if that client doesn't hear? It just moves on. What happens to that conversation? Well, times that by all the different wireless clients and all APs in that environment, right? And you've got a lot of what I consider unnecessary management overhead in that environment. Really doesn't be needed. How do you fix that? Right? So again, you want to reduce the SSIDs. If you have an SSID that's used once every special occasion, disable it. If you have SSIDs that aren't being used, right, turn them off, right? There's no harm in that, right? You'll notice that will help with reducing the airtime utilization of just pure management frames, right? disable lowest data rates. We'll talk about this here in another slide. And then again, increase the beacon interval. The thing that you want to watch for is the very thing that we were trying to fix, which are probe swarms. A nice conversation here that talks about probe swarms and some of the things that are being done to address that. And then again, how do you validate that is by control reporting and spectrum analysis, right? So the fourth one is 5 gig only design. So again, what does 5 gig only design do? Well, obviously it reduces the ability for clients to use 2.4 band, right? And it also forces dual band clients to use the 5 gig band exclusively. Where you make these changes on the controller for AP depending on your architecture. Then also there's another step. If you have an SCCM or MDM type solution, you can actually push this out through GPO as a policy. Word of caution though, if those devices are taken home or those devices used in other spots, and that user doesn't have the ability to change it, then that user is at home and only has a 2.4 environment, right? You can see where that's going. So again, know your devices, know your people, know your architecture, before you come into some of these conversations. And what you do is, real simple. You just turn off the 2.4 gig radio. A lot of meshes will use 2.4 for backhaul, so keep an eye on for that. You definitely don't want to turn off your backhaul. And then if you are using it for mesh, go ahead and just disable the clients that are 2.4 capable that are on the SSID. Just go ahead and just disable those SSIDs to be broadcast on 2.4. On the client side, you can modify the client roaming aggressiveness. You can modify the client preferred band to 5.0. And if you are interested in what devices are capable, because I know that wireless and sometimes the desktop teams in larger organizations aren't the same people. And sometimes, devices have a shelf life. Client devices sometimes are in the environment for 5 years. So sometimes it gets a little hard to know what your devices are capable for, your endpoints, right? Your wireless endpoints. You can run a report on all vendor controllers. They all have it. Have a look at the client 5 gig radio, have your total number of 5 gig supported clients, and then what's really, number of 5 gig capable clients on 2.4 band. Right? Again, things to look out for, like we mentioned, 2.40 capable clients, 2.4 gigahertz printers. I've noticed a lot of executives, they will have their printers in their office on the 2.4 just so they can print. So you want to definitely keep that in mind when you're thinking about that. Again, know your air, know your infrastructure, and then keep an eye on the non-Wi-Fi CCI. So this is really prevalent, and this is coming up more and more again. And I mentioned earlier in the presentation that when I say just moving everything to 5 gig band is not going to address all the issues, or moving everything to a 20 megahertz and then possibly even 5 gig band, that's going to solve the problems. It used to be really rare that we'd be in 7 signal with the customer, we would see non-Wi-Fi interference, and now we're seeing it every day, at least every day with customers, and we see it on the spectrum analysis on the waterfall. And what I'm talking about is that you will see in a waterfall graph movement on like maybe let's say a 2 megahertz wide channel right in Uni 3, and it's constantly hot. So on the spectrum graph, as it waterfalls, it's just a straight line and it never changes. It's there 24/7, 365. If you move everything, or you have client devices running on that channel, that is non-Wi-Fi interference. That is going to be interference. That is going to cause congestion. That is going to cause slowdown, right? So that basically will cause everything we're trying to resolve. And it used to be that non-Wi-Fi interference, I didn't see it a lot in corporate environments, and now I'm seeing it literally every day with different customers. And it's not rogue. It's not something that let's use a 2.4 of a microwave or a phone, for 5. It is actually a business critical application or some type of IoT or some type of device that actually is there on purpose. So it's not like a rogue device. So you have 2 ways of fixing interference in a Wi-Fi network, right? You can either get rid of the interference by turning it off, or you can move channels. So when I talk about going into 5 gig only design and we moved even to smaller channels, channel widths, keep an eye on that non-Wi-Fi interference. If you've got something in a uni channel that you're using to, move your guys to another plan, right? Just avoid, especially if it's business critical. And again, how to see, what things where they're at, how things progressing is to use, again, a spectrum analysis, control reporting. And then if you guys do move to the route with having the devices through GPO, do a preferred band, again, your MDM client solution should be able to report and just see how that is. Right? So I wanted to mention some other options here that I didn't get a chance to address. And one is with 802.11x and EAT, right, for enable fast roaming. And you'll notice I put a little caveat there, unless it's a VoIP client with a double asterisk, 303 best practices, right? So why would we not want to do that with voice, right? So the voice devices usually are roaming, like left and right, moving. The authentication process takes quite a bit. There's a lot of steps, especially as you roam. EAT fast roaming does help, but a lot of people have moved just to WPA2, pre-shared key when it comes to that, just because that process takes a little too long with VoIP phones. So again, best practice or suggestion, sometimes with VoIP, that's, you might not be able to do that. Another example, which I referenced, is the fast and initial link setup protocol, which is out of scope for this, but we can talk to it at a later date. And then also just be mindful of using bonded channels of any size in high deployments. So look at your spectrum, look at your channel plan. If you're using bonded channels and there's a lot of Wi-Fi clients, a lot of APs in the area, you're doing yourself quite a bit of harm. There's no need to be at 80, no need to be at 160. Think about why that is and drop that down. If again, spoiler alert, after you've made there is an issue, just not really needed to be there. And then also we talked about disabling data rates, right? So 11B data rates, again, these data rates, are pretty small. And again, we referenced the 2.4 band, so it's not in the world if we can't drop the 2.4. There's some things that we can do. But if you might remember and might question, what is the preferred data rate, right? The minimum for at least for 7 signal is like, we at least want to be over 12 megs, for a data rate. As you guys are aware, the data rate is not the same as the TCP/IP data rate, right? There's quite a bit of overhead, but it is directly relation to how fast you can actually do those upload and downloads on that Wi-Fi speed, right? So you have a Mac, brand new Mac laptop, and it's got a 3x3, and you look at it and its data rate is terrible. Well, depending on different calculations, rule of thumb, anywhere from 75% to 65%, is going to result into how fast to the TCP data rate is actually going to be. So that device is actually going to be pretty slow. And then also, why did that device decide to connect at that data rate, right? Again, if you looked at our previous examples, right, our APs, they start out really slow, right? So why did this device pick that rate? Another thing to look for too is roaming, especially on Apple devices. When you're making the decision about if you've got a high-dense environment, you need to look at the client ports and make sure that those devices are actually set for roaming, right? So I'm going to pause for a second. I've got somebody knocking on my door here. Kelsey, can you turn it to questions real quick? That's all really had here.
Yeah, of course, we can get started with some questions here. I see a few of you have dropped in where you're joining us from, so we'll go ahead and catch up here. Let's see. We have Ernie joining us from Atlanta, working from home. Thank you, Ernie. We have Anders joining us again from Norway. Thank you, Anders. Great to hear from you today. Let's see who else we have here. We have Chris joining us from Pittsburgh. Thank you, Chris. A couple more people here. All right. We kind of caught up here, Chris. I think you might be on mute.
I am. Sorry about that, guys.
No problem. Chris, do you want to take it away with questions here? Awesome.
Absolutely. I'm trying to make it bigger. Let me see here. I've got the question. There it is. Okay, I'm caught up. Just give me 1 second, Kelsey. Let me read these here. Can we get the slide deck for that? Oh yeah, absolutely. You already answered that one.
Yep. Yeah, just
Got a question. Oh, go ahead.
Nope. Go ahead, Chris. You're good.
Got a question about newer AP models in the market that claim to serve 1,000 end devices, marketing or fact. I am not going to be ugly to marketing, Kelsey. So I hope you're smiling. It's real easy to pick on marketing, but I started thinking it from a marketing perspective. In all these data sheets that we get, they always show like what is the absolute best, most capable of all things being perfect. How fast these devices can do. And this person asked, these new AP models, they can serve 1,000 end devices, right? Is that fact? Well, in the conditions or environment, maybe so. I like to think of it as Formula One racing. You've got these Ferraris, you've got these Porsches and BMWs. Those devices can run. I mean, those cars can run at that speed because everybody else is running at that speed, and there is a closed track, and everything is perfect. So instead of just like marketing, like saying, "Oh, marketing is just crazy with their ideas," it's really like what their best, what the best perfect scenarios is. So take it with a huge grain of salt. If you're not going to be running, Daytona, and you're going to be doing just average stuff, those marketing slides that you've got to pull that information down a little bit, right? So let me get another one here. Okay, all network. Oh, nice. One person makes a comment about 2.4 networks is best effort, only enabling enough 2.4 to produce minimal 2.4 coverage. Definitely, it's a good thought and a good way to do things. There is a big topic in you guess what I'm about to say, the 303 CWP certification, the best practices guide is talking about planning for the least capable, most in use device. So keep that in mind too. If that is your main device, you want to make sure that you build a Wi-Fi network. And this is for everyone, us included, that you keep that, whatever that least capable, most prevalent device used. You keep that in in mind. Okay. A good question. Do you play with the receive density and high density networks like settings? Again, that is very specific on what you're trying to do and what problems you have. I would look more to confirm that I do have a high dense environment. I would look to see, what is causing, some of these issues. I'll give you a great example of a false herring. And again, I'm not picking on MacBooks, but a MacBook is especially the MacBook Pros and the Airs, their architecture is built to roam really quickly because their design, just like the Dell XPS, I know because I was a part of that team back in the day, that product is used to run around a lot. It wants to roam, it wants to move. And so in that architecture, in that setup, it will roam pretty aggressively. And so if you sit a MacBook down, certain MacBook, and it's the noise floor is too high and the ratio is too small, but it might be better for others, you'll see a MacBook just roam left and right, just all day, just back and forth, and it's never physically moved. And every roaming algorithm is a little bit different per protocol and what have you, but some devices are actually more fine-tuned to that. So if there's a lot of noise in that area, everybody else on a Windows machine, not picking, I'm a fan of both, are doing fine and stationary, but you've got other devices that are bouncing around. So again, it's knowing that least capable or even most least capable, most used device, and then understanding that these different client devices are actually, they don't roam just like everybody else does. They're sometimes geared to do a little bit things different. So good question, good response to you about directional antennas. That's a great way to help do that, to produce smaller coverage. Aruba has a setting to beacons. Good question. Aruba has a setting that increases the data rate of beacons. Would this have a negative effect on the overall RF? That is something, the answer is yes on that. And I wouldn't do that. I wouldn't increase beacons in a high dense environment, especially on the physical location. I would definitely do that in a little bit less dense environment. But yeah, it could cause call problems. It's always good to have a spectrum analysis and do that reporting and see, what's happening. And I think that is. Oh yeah, I'll do one more, Kelsey, if we have time. Right? I think we got 2 minutes.
One more works.
One more. Okay. Wouldn't fast roaming be beneficial for VoIP wireless phones, since they would, know which AP to move to next? Yeah, absolutely. And fast roaming was actually done specifically that in mind. But again, according to 303 and what I've seen, and then also with other vendor certs that I've done and worked with, it takes too long, especially in hospital environments or clinical environments or warehouses where somebody has a VoIP phone that's it's Wi-Fi VoIP phone. The way it moves so fast through the area, it spends almost all of its time trying to authenticate to the different APs, and it just actually causes an end user experience. And we're actually seeing this with scanners now in Android operating systems. So yeah, it was meant for that, but sometimes it just takes too long, and how much that device is actually moving around. Sometimes you have to say, you know what, we're going to make voice another SSID network on its own, and we're just going to hopefully do a really a pre-shared key, and hopefully to speed that up for the end user experience. So yeah, great questions, guys. I really appreciate that. And Kelsey, I believe that is all the questions.
All right. Awesome. Well, thank you to all of you for dropping your questions in there. We love hearing from you. And thank you to Chris for walking us through today's topic. A lot of great feedback, really interesting presentation. And as I mentioned before, this will be emailed to all of you tomorrow with today's recording as well, and it will be up on our socials later this afternoon. So thanks to everyone, and thanks for giving us 45 minutes out of your workday to dive through this. Hope to see you guys next week.
Thank you, everyone. Thank you, Kelsey.
Thanks, Chris. Bye, everyone.